Hello, ladies and gentlemen. Welcome back to Chemical Composition and Reactions. Today we are going to talk about part 3 for the oxidation numbers, which is how to determine a compound's formula using oxidation numbers. Our example today is going to deal with sodium, which is Na, and oxygen, which is O. If you know your rules, you already know that the oxidation number of sodium is a -1 because it is an alkali metal, and you know that the oxidation number of oxygen is a +2 most of the time. Now, if we look at just the oxygen, we know that if we have a single oxygen element, its total is a +2. No surprises. However, we know that it needs to make the sum of the oxidation numbers equal 0. That's one of the rules you also should know. Now, if I have a +2 and I need it to equal 0 by adding something to it, that means I need a -2, which means if sodium is only a -1, I need to have 2 of them. Now what that means is you can look at these numbers right here and you should be able to determine the subscripts, those numbers written underneath, that are used for the formula. And you should get the answer of Na2O to have 2 sodiums and 1 oxygen in order to figure out its formula. Now, if you found that confusing, that's okay, because although that is the technical method for doing it, there is a much simpler method. This method is called the crisscross method. And to do this, we are going to start by using beryllium and chlorine and see how they combine together. Okay, the first rule for the crisscross method is that you write the symbol of the metallic element first. Now, if you're not familiar with beryllium and chlorine, beryllium is over on the left side of the periodic chart in group number 2, and chlorine is way over on the right of the periodic chart in group number 7, the halogens. Okay? If you don't remember, the metals are on the left side and the non-metals are on the right. So what that means is beryllium comes first. And because it's an alkaline earth metal, we of course know that its oxidation number is a +2. And because chlorine is a halogen, we know its oxidation number is a -1. Now, if we are going to figure out the subscripts for this, you start simply by writing the elements down. And the next rule comes into play. The next rule is the easy part. The positive value of the other element's oxidation number becomes its subscript. Now, if that sounds complicated, it's not. Basically, what that means is the -1 from the chlorine becomes a +1 subscript for the beryllium, and the +2 oxidation number for the beryllium becomes the subscript of 2 for the chlorine. Okay, so we see that you have Be1Cl2. Okay, now we can't just leave it like that because we get to rule number 3. Rule number 3 says leave out any subscripts of 1. They are assumed. Just like when you are doing math, if you have 1x, you don't bother to write the x. Same thing happens here. If there is no number, it is assumed that they are a 1. So your final answer for the formula for beryllium and chlorine would be BeCl2. Okay? Now, for our next rule, we're going to need to use some different elements. Okay? We are going to use magnesium and sulfur. Now, the rules, the first three, still work the same way. The -2 for the sulfur becomes +2 for the magnesium subscript, and the oxidation of magnesium, being a +2, becomes the 2 for the sulfur. Okay, looks nice and simple. We have this beautiful formula, Mg2S2. However, just like in math, there is another rule. In that, if you can reduce subscripts, you need to do it. So, the Mg2S2 will end up becoming MgS. You simply remove the different subscripts and reduce it. Now, if it had been a 2 and a 4, you reduce it by dividing each side by 2. Whatever is needed in order to get the smallest numbers. You'll see sometimes in science these things may not be the way it exists in nature. However, that would have to be determined by experimental procedures in order to figure out what the actual things are. However, this gives you the empirical formula, which is the base formula that would let you know that no matter what the other reactions are, for every 1 magnesium, you will have 1 sulfur. Okay? If you have any questions, make sure that you review through this. Tomorrow we will use polyatomic ions and show how to write them. You do have questions in your homework. If you have any questions as you go through, make sure you ask. I'll talk to you tomorrow.